Hello dear students, I hope you are fine and doing well in your studies. Student, today we are going to start a new chapter, Trigonometric Function. In this chapter, we will study basic examples, some important questions and basic information of trigonometric function. Student, now let us start with the chapter itself. Students, in this class we will study fundamental of trigonometry. In this, trigonometric ratios and identity. The word trigonometry is derived from the Greek word trigon and metron, and it means measuring the sides and angles of a triangle. What is the angle? Angle is a measure of rotation of a given ray about its initial point. The original ray is called the initial side, and the final position of the ray after rotation is called the terminal sides of the angle. Here is the initial side and it is the terminal side. The point of rotation is called the vertex. This is vertex. If the direction of rotation is anti-clockwise, the angle is said to be positive. And if direction of rotation is clockwise, then the angle is negative. Means this is the positive angle and this is the negative angle. This is the basic concept of sign of angles. Angles may be positive or negative. In anti-clockwise direction, they are positive, and in clockwise measurement direction, angles are negative. Means this is the x-axis let and it is the y-axis. If we measure an angle from positive x-axis into the clockwise direction like this, that it is the 45 degree, then it will be minus 45 degree. And in anti-clockwise direction, this is the positive 90 degree as we know. What is the system of measurement of angles? An angle can be measured in the following system. There are three systems: sexagesimal, centesimal and circular system. First is the sexagesimal system or British system. In this system of a complete circular turn is called a degree, of a degree is called a minute, and of a minute is called a second. And in this system, one right angle is 90 degree and 1 degree is 60 minute. This is the symbol of minute, and 1 minute is the 60 seconds. This is the sexagesimal system, British system, or you can say it is the degree system. Now second one is the centesimal system or French system. In this system of a complete circular turn is called a grade, of a grade is called a minute, and of a minute is called second. In this system, one right angle is 100 grade, and 1 grade it is the 100 minute, and in 1 minute it is the 100 seconds. One important note is here: the minute and the second in the sexagesimal system are different with the minutes and second respectively in the centesimal system. Symbols in both systems are also different. Now third one is the circular system or radian measurement. The angle subtended by an arc of a circle whose length is equal to the radius of the circle at the center of the circle is called a radian. In this system, the unit of measurement is radian. This is the representation of radian. As the circumference of a circle of radius 1 unit is 2 pi, therefore, one complete revolution of the initial side subtend an angle of 2 pi radian. Students, more generally, in a circle of radius r, an arc length r will subtend an angle of 1 radian. This is the figure. In this circle of radius r, and arc length of length r subtend an angle that is 1 radian. It is well known that equal arc of a circle subtend equal angle at the center. Since in a circle of radius r, an arc length subtend an angle whose measure is 1 radian, arc length AC, and this is L. The arc length is L. And arc length is proportional to the angle, and let this angle is theta. Means the arc length is proportional to theta, and AB arc length is proportional to 1 radian. If we remove this proportional sign, then we can say arc length AC is equal to k theta and arc length AB is equal to k into 1. Now divide both these. AC upon AB is equal to theta. Theta is equal to AC upon AB. What is the AB? AB is the radius. And what is the AC? AC is the arc length. Let it is L. L upon R. Then you can say L is equal to R theta. This is the important formula. And in this formula, theta is equal to L upon R, which is the angle in the radian. Thus, if in a circle of radius R, arc length L subtend an angle theta, radian at the center, we have theta is equal to L upon R or L is equal to R theta. Students, here are some figures. You can see this is the 1 radian, this is minus 1 radian, and this arc length is 2, radius is 1, then it will be 2 radian. We can use the formula angle is equal to arc length upon radius. In this, arc length is 2, radius is 1, angle is the 2 radian. And in this case, it is minus 2 radian because it is clockwise measurement. One important note is here, if no symbol is mentioned while showing measurement of an angle, then it is considered to be the measured in the radians. If it is written that theta is equal to 15, it implies it is a 15 radian. One more interesting formula, area of circular sector is equal to r square theta by 2 square unit. From where this formula comes? As we know, area of the complete circle is pi r square, and at the center of complete circle, angle is 360 degree or it is equal to 2 pi radian. Corresponding to 2 pi, there is the area pi r square if radius of circle is r. Then for the theta angle, corresponding area will be, and it is equal to the circular sector area, and it will be pi r square upon 2 pi into theta. Now solve it out, it will become r square theta by 2 square unit. This formula is solved now. What is the relation between radian, degree and grade, or in all three systems of measurement of angles? Pi by 2 radian is equal to 90 degree is equal to 100 grade. And in this relation between radian and degree is most important. 1 radian is equal to 180 upon pi degree, and 1 degree is equal to pi upon 180 radian. Let's see some example of interconversion. We want to convert degree into the radian. Means in 90 degree, how much radian? As we know, in 1 degree, there is pi upon 180 radian. Implies in 90 degree, there will be pi upon 180 into 90 is equal to pi by 2 radian. Similarly, 45 degree is equal to 45 into pi upon 180. It is equal to pi by 4 radian. 60 degree is equal to 60 into pi upon 180 is equal to pi by 3 radian. 120 degree is equal to 120 into pi upon 180. It is equal to 2 pi by 3 radian. Now we can convert radian into degree also. If we have pi by 2 radian, then as we know, in 1 radian there are 180 upon pi degree. So in pi by 2 radian, there will be pi by 2 into 180 upon pi. Simplify it, it is 90 degree. Similarly, in pi by 3 radian, there will be pi by 3 into 180 upon pi. It is equal to 60 degree. You can interchange radian into degree and degree into radian. If somebody asked you in 1 radian there is how much degree, this is the most important question. In 1 radian, the relation between 1 radian and degree is here. Now we have to find that in 1 radian how much degree, means we have to substitute the value of pi is here and simplify. Now 1 radian is equal to 180 upon pi. It is equal to 180 upon 22 by 7. Now simplify it. It is the 180 into 7 upon 25. It is 1190. It will be 630 upon 11 degree. Now we have to convert 630 upon 11 degree into degree, minute and second. So 11 is divided to the 630. It is the 555. There is a 80. It is the 70, 77. It is the 3. Here is the remainder is the 3 degree. Now we have to convert degree into minute. As we know, in 1 degree there is 60 minutes. So in 3 degree there will be 180 minutes. Now 11 minus 11, it is 70. 11 6 66. 4 is remainder. Now remainder is minute. As we know, in 1 minute there is 60 seconds. In 4 minutes there will be 240 seconds. Now we have to find 11 240. It is approximate 22 seconds. Means this 630 upon 11 degree is equal to 57 degree, 16 minute, 22 seconds. You can say that 1 radian is equal to approximately 57 degree. Students, now we are going to understand trigonometric ratios for acute angle. Let a revolving ray OP starts from OA and revolves into position OP, thus tracing out the angle AOP. In the revolving ray, take any point P and draw a perpendicular PM to the initial ray OA. In the right angle triangle MOP, OP is hypotenuse, PM is the perpendicular and OM is the base. In this triangle, you can say MP perpendicular upon OP hypotenuse. It will be sine of angle AOP. OM is the base upon OP. It is the hypotenuse. It is cosine of the angle AOP. Similarly, tangent of angle, cotangent, secant and cosecant are listed here. It can be noted that trigonometrical ratios are all real numbers. Students, we will now extend the definition of trigonometric ratios to any angle in terms of radian measures and study them as trigonometric functions, also called the circular function. Consider a unit circle with center at origin of the coordinate axis. Let P, A, B be any point on the circle with angle AOP is equal to x radian. Length of RKP is x. As we know, cos x is equal to base upon hypotenuse. What is the base? Base is the OM and hypotenuse is 1. Means cos x is equal to OM upon OP. For the point P, the length OM is A and OP is 1. Means cos x is equal to A. Similarly, sin x is equal to B. Since triangle OMP is a right angle triangle, we have OM square plus MP square is equal to OP square, or you can say A square plus B square is equal to 1. Thus we can write down cos square x plus sin square x is equal to 1. This is the famous identity of trigonometric ratios. Students, since one complete revolution subtend an angle of 2 pi radian at the center of the circle, angle AOB is right angle. It is equal to pi by 2 radian. Similarly, AOC pi radian, AOB 3 pi by 2 radian, because the portion AOB is the 1/4 part of complete circle and AOC is the half part of the complete circle and AOD is the 3/4 part of complete circle. All angles which are integral multiple of pi by 2 are called the quadrilateral angles. Students, the coordinates of point A, B, C, D are respectively 1, 0, 0, 1, -1, 0 and 0, -1. Therefore, for quadrilateral angles, what is the meaning of angle 0? Angle 0 means this OP rays comes to OA line, then angle will be 0, and corresponding to this, the point 1, 0 is obtained, and for the angle 0, the points P converted into 1, 0. Initially point P is A, B, then we can say cos of angle is equal to A and sine of that angle is equal to B. Now, if P is shifted to A, then angle is shifted to the 0, X is shifted to the 0, and the point A, B is shifted to 1, 0. That's why one can say that cos 0 is equal to 1 and sine 0 is equal to 0. If this point P moves towards the B point, then angle X is converted to pi by 2 and point P is transferred to the point B, means A, B is shifted to 0, 1. It implies that cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1. This is listed here. Similarly, for if the P point is transformed from P to the C, then angle will be pi and cos pi is equal to -1 and sin pi is equal to 0. And if angle is 3 pi by 2, then point is 0, -1, cos 3 pi by 2 is 0 and sin 3 pi by 2 is -1. If angle is 2 pi, then point will be 1, 0. For that, cos of 2 pi is 1 and sin of 2 pi will 0. Students, now we take one complete revolution from the position OP. We again come back to the same position OP. Thus, we also observed that if x increases or decreases by any integral multiple of 2 pi, the values of the sine and cosine function do not change. Thus, we can say that sine 2n pi plus x is equal to sine x and cos 2n pi plus x is equal to cos x. Student, as we know, in a triangle POM, cos x is equal to A and sin x is equal to B. The point A, B corresponding to the cos x and sin x respectively. If somebody is saying that sin x is equal to 0, means B is equal to 0, then you have to check the coordinates where B is 0. The one coordinate is A and second is C, where B, or you can say Y coordinate is 0, means corresponding angle will be 0, pi. Similarly, if we take the term 2 pi, 3 pi, minus 2 pi, all that angles, the value of sin x is 0. You can say that when x is the integral multiple of pi, then the value of sin x is 0. Similarly, if cos x is equal to 0, then you can observe the point B and C. At the point B, x coordinate is 0. And what is the x coordinate? X coordinate corresponding to the cos of that angle, means corresponding to pi by 2 and 3 pi by 2, or their complete term, minus pi by 2, minus 3 pi by 2, 5 pi by 2. It is the odd multiple of pi by 2. Their cos x is 0. You can say that cos x vanishes when x is an odd multiple of pi by 2. Thus, sin x is equal to 0 implies x is equal to n pi, where n is an integer, and cos x is equal to 0 if x is the odd multiple of pi by 2, where n is an integer. We now define other trigonometric functions in terms of sine and cosines. Cosec x is equal to 1 upon sin x, and it is defined where x is not equal to n pi. Similarly, sec x is equal to 1 upon cos x, where x is not equal to 2n plus 1 pi by 2. Similarly, tan x is equal to sin x upon cos x, where x is not equal to 2n plus 1 pi by 2, where n is an integer, and cot x is defined or is equal to cos x upon sin x, where x is not equal to n pi, and in mathematics it is compulsory that the denominator is never be 0. That's why these points are excluded. Up to now we have shown that for all real x, sin square x plus cos square x is equal to 1, and it follows that 1 plus tan square x is equal to sin square x, and 1 plus cot square x is equal to cos x square x. Think about x is not equal to 2n plus 1 pi by 2, and here x is not equal to n pi, and it is so easy because tan and sec contains cos x in a denominator and it will never be 0. That's why x is not equal to 2n plus 1 pi by 2. And similarly here in denominator there is sin x. So sin x is not defined for x is equal to n pi because sin x in the denominator, and denominator never be 0. Students, now we are going to understand the sign of the trigonometric functions in the different quadrants. Here is the system of quadrants. This is the first quadrant, it is second, it is third and fourth. And as we know, cos x is equal to A and sin x is equal to B. In first quadrant, A and B is positive, means coordinate is positive. Then you can say in first quadrant all trigonometric ratios are positive, because if sin positive, cos positive, then tan is also positive. That's why all trigonometric ratios are positive in the first quadrant. In second quadrant, A is negative. If A is negative, then what will happen? Then cos x is negative. If cos x is negative, then cot is also negative. Means in second quadrant, except the sign and a reciprocal of the sign cos x, all trigonometric ratios are negative, because remaining trigonometric ratios contain cos x, which is negative. In second quadrant, all trigonometric ratios except sin and cos x are negative. You can see that sin and cos x are positive in the second quadrant. In the third quadrant, the point will be minus a comma minus b, means cos is also negative, sin is also negative, implies only tan and cot are positive and other trigonometric ratios are negative in third quadrant. And similarly, if theta lies in the fourth quadrant, then A is positive and B is negative. You can say that sin is negative. If sin is negative, then in the fourth quadrant, all trigonometric ratios except cos and sec are negative. Cos and sec are positive and remaining are negative. This is the basic sign scheme, or you can say basic sign of trigonometric ratios. Students, so far we have understood the basic concept of sign of trigonometric ratios. Now it is time to memorize this. The sign of trigonometrical ratios in different quadrant in the 4-word phrase after school to cinema. The first letter of the word in the phrase is A. This is taken to indicate that all trigonometric ratios are positive in the first quadrant. The first letter of the second word is S. This indicates that sin and its reciprocal are positive in the second quadrant. The first letter of the third word is T, which may be taken as to indicate that tangent and its reciprocal are positive in the third quadrant. The first letter of the fourth word in the phrase is C, which may be taken as to indicate that only cosine and its reciprocal are positive in the fourth quadrant. And here is the quadrant system. Here is all positive, sin cosec, tan cot and cos sec are positive and remaining trigonometric ratios are negative. Now we are going to study trigonometric ratios of allied angles. What is the allied angle? Allied angles are also called as related angles. If theta is any angle, then minus theta, pi by 2 plus minus theta, pi plus minus theta, 3 pi by 2 plus minus theta, 2 pi plus minus theta, etc. are called allied angles. What is a supplementary angle? Two angles are said to be supplementary when their sum is equal to 2 right angle, means 2 into pi by 2 is equal to pi. The supplementary of any angle theta is 180 minus theta. As we know, the sum of these angles are equal to 180, which is pi. Now we are going to study trigonometric ratios of minus theta angle. Let theta be an angle in the standard position in the first quadrant. Let its terminal sides cuts the circle with center O and radius R in P. This side cuts the circle at P. Let P dash, X dash, Y dash be the point of the intersection of the terminal side of angle minus theta in the standard position with the circle. Now, angle MOP and angle MOP dash numerically are equal. P and P dash have same projection, M in the x-axis. In the triangle OMP and OMP dash, X is equal to X dash and Y is equal to minus Y dash. This angle is theta and this angle is minus theta. Now in the triangle MOP, what is the value of sine theta? And in the triangle MOP dash, what is the sine minus theta? Sine minus theta is equal to Y dash, means MP dash upon OP dash. It is equal to Y dash upon R. Here it is mentioned. And sine theta in the triangle MOP is equal to PM upon OP. What is the value of PM? PM is Y and OP is R. As we know, Y dash is equal to minus Y. So we can write sine of minus theta is equal to Y dash upon R and is equal to minus Y upon R. And Y upon R is sine theta. So we can say sine of minus theta is equal to minus sine theta. And similarly, we can find that cos of minus theta is cos theta, tan of minus theta is minus tan theta, and so on. And similarly, if theta is in the other quadrants, then above results can also be proved. Now here is the trigonometric ratios for angle pi minus theta. Let theta be an angle in the standard position in the first quadrant. Let its terminal sides cuts the circle with center O and the radius R at P. Let P dash, X dash, Y dash be the point of intersection of terminal side with an angle pi minus theta. With the circle, let M and M dash be the projection of P and P dash respectively in the x-axis. Since the triangle OM dash P dash is similar to the triangle OMP, X dash is equal to minus X and Y dash is equal to Y. Sin pi minus theta will be equal to Y dash upon R, and as we know Y dash is equal to Y, it is Y upon R, which is the sin theta. That's why we can say that sin 180 minus theta is equal to sin theta. Similarly, cos 180 minus theta is minus cos theta, and tan 180 minus theta minus tan theta, and so on. Now we are going to list the trigonometric ratios in different quadrant. For first quadrant, all trigonometric ratios are positive. We can easily prove that sin pi by 2 minus theta will be cos theta, and so on. In the first quadrant, all trigonometric ratios are listed here. Similarly, in the second quadrant, sin pi by 2 plus theta is cos theta. In the second quadrant, by the rule, sin and cosec are positive and rest trigonometric ratios are negative. So here is the minus signs. For the angle 3 pi by 2 minus theta, angle lies in the third quadrant. And in the third quadrant, only tan and cot are positive and other trigonometric ratios are negative. Similarly, 3 pi by 2 plus theta lies in the fourth quadrant, and in fourth quadrant, cos and sec are positive and rest are negative. Here is the list of trigonometric ratios. It is a minus theta, 180 minus theta, it is 180 plus theta lies in the third quadrant, and it is 360 minus theta lies in the fourth quadrant, and it is again first quadrant. And by the rule, in the third quadrant only tan and cot are positive, rest are negative. That's why tan and cot positive and rest are negative. In the fourth quadrant, only cos and sec are positive, rest are negative. And we can easily prove all allied angles by using the circular system.